Now, hello everyone. Today I am going to explain about simplex method. Now solve the LPP by simplex method. The given problem is in which form? Maximization of z is equal to, subject to the constraint, first constraint, second constraint, third constraint, and decision variables greater than or equal to 0. To convert this into the first, we have to do one problem in simplex method. We have to convert that into the standard form. While converting into the standard form, it is already in the maximization of z. That's why I'll write as it is. Now the first constraint is having less than or equal to symbol. That's why plus s1 is equal to 1. I added one slack variable called s1 is equal to 1. The second constraint is also less than or equal to symbol. That's why I'm adding one more slack variable called s2 is equal to 2. And the third constraint is also having less than or equal to symbol. In order to make this also in the equation form, I am adding one more slack variable called s3 is equal to 3. Now all the decision variables and slack variables greater than or equal to 0, positive. All decision variables and slack variables are greater than or equal to 0. This is the standard form. Now here, after that, we have to start the simplex table. While doing the simplex table, we have to draw. The first table is called initial simplex table. Now I'll draw the initial simplex table. Just observe everybody. First column, second column, and first column is for CB, second column is for B, and the middle one is for body of the simplex table. How many variables are there here? X1, X2, and S1, S2, S3. These many variables are there. After that, constant, and the last column is for minimum ratio, MIN ratio. Last column is for minimum ratio. Now here I'll write CJ as, now whatever the values are there in the objective function, coefficient of x1, above coefficient of x1 3 is there, coefficient of x2 we have 2 is there. Any coefficient of s1 is there in maximization of z, s1 coefficient of s1 is 0, coefficient of s2 0, coefficient of s3 0. If you observe in the objective, using the objective function, whatever the values are there, we have to write in the CJ, near CJ. And next we will fill the objective, we will fill the body of the simplex table. Now here coefficient of x1, coefficient of x2, coefficient of s1, coefficient of s2, coefficient of s3, and constant terms we have to write. The first coefficient of x1 is -2, 1, coefficient of s1 1, s2 0, s3 0, constant term is, right side constant term is 1. Now the second constant, coefficient of x1 1, x2 0, s1 0, x1 1, x2 0, s1 0, s2 1, s3 0, constant term 2. The third one, coefficient of x1 1, coefficient of x2 1, coefficient of s1 0, s2 0, s3 1, constant, right side constant is 3. And draw one column like this, one more column like this. Now using the three constraints, the coefficient of x1, x2, s1, s2, s3, I wrote here in this one. This is the body of the simplex table. Now we have to fill this column as well as this column. Now this B means basic variables. B means from where we should write, wherever you get. See, if you observe the variables of s1, s2, s3, here we have got 1 0 0 0 1 0 0 0 1. Wherever you get identity matrix 1 0 0 0 1 0 0 0 1, that variables are called basic variables. In the first problem we have got identity matrix near s1, s2, s3. That's why s1, s2, s3, the three variables are basic variables. Now coefficient of basic variables in the objective function. In the objective function, the coefficient of basic variables is Coefficient of basic variable is 0. Coefficient of S2 is 0. Coefficient of S3 is also 0 in the objective function. Coefficient of S1 0. Coefficient of S2 0. Coefficient of S3 0. Here we have to write. Now this row is called index row. How to calculate this index row? I will tell you. We have to calculate this index row with the help of Zj minus Cj. Formula is Zj minus Cj. How to calculate Zj minus Cj? I'll tell you. Here to get the element here, 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 here and here. Now to find the values here, what we have to do? CB into the first column, CB column into the first column. That means 0 into minus 2 plus a 0 into 1 plus a 0 into 1 minus Cj minus 3. Like this you have to calculate. 0 into minus 2 0 plus 0 into 1 is 0 plus 0 into 1 is 0 minus 3. How much you'll get? Minus 3. In the same way here to get the element here what we have to do? This column into this column. That means 0 into 1 plus 0 into 0 plus 0 into 1 minus Cj minus 2. Minus 2 you'll get. Because we can write as it is. Why? Because this is initial simplex table. Here the three elements are 0. 0 into anything is 0 minus Cj means whatever the values are there, quite opposite value if you write, that's enough. Because this is initial simplex table, that's why. Now for the remaining tables we have to calculate very much carefully. Now here how we calculated Zj minus Cj? This column into this column, this into this, plus this into this, plus this into this, minus this. Here. In the same way, the next one also, this into this, plus this into this, plus this into this, minus 2. In the same way, the remaining columns also we have to write. Now, like this, we have got index table. Now, what we have to do with the index table? The most negative value in the index table, indexed row. In the index row, the most negative is minus 2, minus 3, minus 3, minus 2, 0, 0 is there. The most negative one is minus 3. Put one arrow here. Now coming to the minimum ratio. Now here we choose the first column called x1. Now coming to the minimum ratio, 1 by we choose the first column, that's why 1 by minus 2. 1 by minus 2 is minus negative value. 1 by minus 2 is minus 0.5. Minus 0.5 is negative. Negative value or positive value you write down. Now the second value is 2 by 1. 2 divided by 1 is 2. 3 by 1. 3 divided by 1 is equal to 3. Now in the minimum ratio what we have to do? Whenever you get a negative value, just ignore, omit. Out of positives and zeros only you have to choose the minimum value. We have to choose the minimum values only positive and 0. Now here out of here the first value is negative, that's why just I ignored, I omitted, and the remaining 2 and 3. Second row value is 2, third value is 3. Out of these two, the most minimum value, the minimum value is 2. That's why one arrow like this I have put. Now the coincide value, these two elements, so you come this side and minus 1. Now the coincide value is, coincide number is 1. This element is called pivot element. This column, first column is pivot column. Second row is a pivot row. The coincide element is pivot element. Now here, if you come this side, from this side to this side, here one element S2 is there. Now if you come to this side to above, here one element is called x1 is there. That means here S2 is leaving variable, whereas x1 is entering variable. Now I am not at all touching s1 as it is, I am writing here. If you observe this one, s2 is leaving variable, whereas x1 is entering variable. S3 I did not touch, as it is I wrote. And above x1 whatever the value is there, above x1 whatever the value is there, 3 is there. 3 as it is. About s1 0 is there, about s3 0 is there. That's why I wrote as it is. Now here x1 is entering variable, whereas s2 is leaving variable. Now above x1 3 is there, that's why I wrote 3 here. Above s1 0, above s3 0, as it is I wrote. Now from here what we have to do is we have to do simplification. The procedure of simplex here we will start. Now this is the first iteration. The first iteration of the simplex table. This is the initial simplex table. Now here what is the procedure? Here whatever the pivot element we have got, we have to convert the pivot element into 1, the above element into 0, the below element into 0. Here by our luck here already 1 is there, that's why we will write as it is. Now the procedure of simplex is we have to convert the pivot element into 1, the above element into 0, the below element into 0. That is our work. Now already in the pivot, inside of the pivot element already 1 is there. That's why I am writing as it is 1 0 0 1 0 2. I am writing as it is. Now what we have to do? This element as well as the above element and below elements into zeros by doing some elementary row operations. Here to convert this is the first row is R1, second row is R2, third row is R3. You just think like that, R1, R2, R3. Here in place of -2 we have to get 0. To get 0 there in place of -2, which type of operation we have to do? Elementary row operations. While doing the elementary operations, always use the second row. With the help of this second row only you have to perform the operations. I am converting this element into 0 with the help of second row. I have to convert this element into 0 with the help of second row only, always remember, that is the rule. Now this is -2 occurs in R2. R2 is equal to R2 plus 2R1. I'll do R2 plus um, uh, no, no. Now this element is there, this is R1. Here -2 I am going to convert into -2 into 0. -2 is R1. R1 is equal to R1 plus 2R2. R1 plus 2R2. R1 first I will write R1. What is our R1? -2 1 1 0 0 1. 2R2. 2R2 is 2 0 0 2 0 4. Adding plus 2 minus 2 get 0 1 1 2 0 5. Now what I have got? 0 1 1 2 0 5. Now this element into 0. To convert this element into 0 with the help of the second row. Now which type of operation I have to perform? R3. That element is there. This one is there in near R3. R3 is equal to R3 minus R1. R3 minus R1 means R3 1 1 0 0 1 3. R1 is 1 0 0 1 0 2 minus 1 minus 1 0 1 minus 0 1 0 minus 0 0 0 minus 1 minus 1 1 minus 0 1 3 minus 2 1. Now 0 1 0 minus 1 1 1. Now once again I will tell you, we have to convert the procedure of simplex is we have to convert the pivot element. Here inside of the pivot element 1 is there already, that's why I wrote as it is. If you have inside of pivot element -2 or 1/2 or +5 or -5 like that, any element is there, first we have to convert into 1 this element, and then the above element pivot element pivot element below element into zeros by doing some elementary row operations. That means you with the help of the pivot element row, now again we will find the index row. Index row is again Zj minus Cj. Zj minus Cj means this into this plus this into this plus this into this minus Cj. Now tell me, 0 into 0 plus 3 into 1 plus 0 into 0 minus 3. 0 0 into, do the simplification separately if you feel any difficulty. 0 into 1, 0, plus 3 into 0, 0, plus 0 into 1, 0, minus 2. Simplifications, if you feel any difficulty, do separately. 0 into 1, 0, plus 3 into 0, 0, plus 0 into 0, 0, minus 0. Now here the next one, 0 into 2, 0, 3 into 1, 3, 0 into minus 1, 0, minus 0, 3. Here 0 into 0, 0, 3 into 0, 0, 0 into 1 is 0, minus 3 is 0. Now here 0 into 5, 0, 3 into 2, 6, 0 into 1, 0. If you add this into this, 0 into 5, 0, plus 3 into 2, 6, plus 0 into 1, 0. That's why 6 we will get here. Now if you extend the table, again we will find the most in the index. Observe the index row very much carefully. Now how many iterations we have to do? This is the initial simplex table. This is the first iteration. How many iterations we have to do like this means whenever we get, when we will get the optimum solution, if you get all the index row elements are greater than or equal to 0. If all the index row elements are positive or zeros greater than or equal to 0, we reached the optimum solution. Then we can stop the iterations and we can write max z is equal to the right side corner, whatever the value we have got, we can write it. But here whenever at least one or more than one negative values occurs in the index row, we did not reach. What is the meaning of that? We did not reach the optimum solution. Just observe the index row very much carefully. Here minus 2 is there. When we will reach the optimum solution, all the index row elements are greater than or equal to 0. Then only we can reach the optimum solution. Now here minus 2 is there. That means we did not reach. Now the procedure again, we will start the simplex procedure. Identify the most negative in the index row. Identify the most negative in the index row is this one. Put one arrow. Now coming to the minimum ratio. That means I choose the second column, x2, second column. Now minimum ratio 5 by 1 is equal to 5. 2 by 0, 2 by 0 is equal to infinity. 1 by 1, 1 by 1 is equal to 1. Now here in the minimum ratio, any negative values or infinity values just ignore. Out of zeros and positives only choose the most minimum value. Any negatives or infinity just omit or ignore that value. Out of positives and zeros only we have to choose the most minimum. Here 5 is there. Here this one infinity is there. Just ignore. 5, 1. Out of 5 and 1, which one is the most minimum? 1 is the most minimum. Put one arrow like this. Now coming to this side, the coincide value is this one. Now here S3 is a leaving variable. If you come to this side to this, you will get S3 is leaving variable, whereas X2 is entering variable. Here S3 is leaving variable, whereas X2 is entering variable. Above X2 how much value is there? 2 is there. Above X2 2 is there. That's why S3. I'll remove S3. In place of S3 I'll write X2 because X2 is entering, S3 is leaving. Above X2 I'll write, above X2 is there, 2 is there. The remaining as it is, I'll write X1 as it is, X1 3, S1 0. I'll write as it is. Now here the pivot element is 1. The procedure of simplex is convert the pivot element into 1, the above elements into zeros. Already in the inside of the pivot element already 1 is there. That's why I'll write as it is. 0, 1, 0, minus 1, 1, 1. Already inside of the pivot element 1 is there. That's why I'm writing as it is. The above elements, here 2 above elements are there. Inside of the above the pivot element we have 2 rows are there. The 2 rows, these 2 elements we have to convert into zeros. Already second row having already 0. That's why again this one also I am writing as it is. 1 0 0 1, 0, 2 as it is. Now I have to convert this element into 0 with the help of the third row, with the help of the pivot element row. Now I have to convert this element into 0 by doing some suitable elementary row operations. That is what I am doing. I have to convert this element into 0. That element is there, R1. R1 is equal to R1 minus R3 with the help of the pivot element row. R1 minus R3. R1 is, our R1 is, tell me the R1. R1 is 0, 1, 1, 2, 0, 5. R3 is 0, 1, 0, minus 1, 1, 1. R1 row is this one, R3 row is this one, R1 is this one, R3 with the help of pivot element row. Now subtracting 0, 1 minus 1, 0, 1 minus 0, 1, 2 plus 1, 3, 0 minus 1, minus 1, 5 minus 1, 4. I'll write 0, 0, 1, 3, minus 1, 4. Now we will find the index row elements. Now we will find the index row elements. Again using the formula Zj minus Cj. How to calculate Zj minus Cj? This into this plus this into this plus this into this minus Cj. Cj is how much? Minus 3. Tell me carefully. 0 into 0, 0 plus 3 into 1, 3 plus 2 into 0, 0 minus 3, 0. Here the 0 into 0, 0 plus 3 into 0, 0, 2 into 1 minus 2, 0. Here 0 into 1, 0, 3 into 0, 0, 2 into 0, 0 minus 0, 0. Here 0 into 3, 0, 3 into 1, 3 minus 2 into 1, 2 into minus 1, minus 1, 3 minus 2, minus 0. 3 minus 2 is 1. 3 minus 2 is 1. 0 into minus 1 is 0. 3 into 0, 0. 2 into 1, 2. Minus 0, 2. Now here 0 into 4, 0. 3 into 2, 6 plus 2 into 1, 2. 6 plus 2, 8. Now if you observe the index row elements, how to I calculated index row, understood? This, to get this element, we have to multiply this into this plus this into this plus this into this minus Cj above. In the same way, to get this element, this into this plus this into this plus this into this minus Cj, like that. Now if you observe the index row elements, we have got all the index row is greater than or equal to 0. 0, 0, 0, 0, 1, 2. Oh, this is the index row, not this one. If you observe all index row elements are greater than or equal to 0. Therefore, we reached optimum solution. What is the optimum solution? This is the optimum solution. Max z is equal to 8 at, now all the index row elements are greater than or equal to 0. Therefore, we reached the optimum solution. Max z is equal to whatever the right side corner, whatever the value is there, that is the answer. Max z is equal to 8 at x1 is equal to, x1 is equal to 2, x2 is equal to 1 and s1 is equal to 4. No need to write. That means max z is equal to 8 at x1 is equal to 2, x2 is equal to 1. If you want, in the given problem, if you substitute this x1 and x1 value and x2 value, you will get 8. Max z is equal to 3x1 plus 2x2. If you substitute x1 is equal to 2 and x2 is equal to 1, again you will get a max z is equal to 8 only. Now if you substitute this x1 and x2 values, in the objective function, it will get satisfied. This is the simplex method procedure. Okay, thank you.